Today we're talking about what's called rational expressions. Phones turned upside down, eyes up here. Okay. Rational expression is nothing more than a fraction. It's got a top, it's called numerator. It's got a bottom, it's called denominator. The only difference is they're polynomials. So what's a polynomial? These guys are polynomials. These guys are polynomials. They all have variables. They're algebraic. What's algebraic? Anything that was a variable, anything that varies, anything that we don't know. That's called algebraic. Okay? So all we're doing today is really reducing fractions. That's all we're doing. Reducing fractions, something you guys have been doing since elementary school. Okay? In fact, the first two are from back then. All right, so that's what we're doing. We're just reducing fractions. So I'm going to start with two examples that you guys have been doing. You could probably do it in your head, but I'm going to do them a little slower because I'm going to show you what process. Okay, so let's look at the first one. Okay, so 12/15. So when you're reducing a fraction, how do you do it? Whether it's on your head or most of you guys can do this in your head, but some of you guys do it on paper. However you reduce fractions. How do we do it? How do we reduce fractions? What's the thought process?
You have to find the greatest common factor between two.
There you go. Yeah, that's it. Find the biggest number that can divide into both of them equally, right? So I can't pick like 12 because 12 goes into the top, but it doesn't go into the bottom evenly, right? So you pick the biggest number. So what happens to be the biggest number here? 3. So this is what you do in your head. I'm going to write it down, but this is what you guys do in your head. You guys are pretty good at this because you guys have been doing it for a while. You're like, okay, I can divide this guy by 3. 3 times 4, right? And I can divide this guy by 3. 3 times 5. And then in your head, you're like, hey, they both have 3s. Those cancel out, right? They don't cancel out. They're still there. But I call them what's called giant ones. They're shared, right? Because 3 divided by 3 is 1. So now on top, we have 4 times 1. On bottom, we have 5 times 1. And there you go. You just reduced the fraction. Now, I know a lot of you do that in your head, which is great. Keep doing that. But that's the thought process that goes in here. The reason I'm doing it slow and the reason I'm writing everything down is because when we get to the harder ones, we need that process. We need a plan. Okay, so let's do B. What's the biggest number?
4.
That goes into both 24 and 32. 4 goes in, but I think a bigger number. I think 8's the biggest. So this number is 8 times 3 and 8 times 4, right? 8 divided by 8 makes 1. You get 3/4. So 3 times 1 and 4 times 1. That's all we're doing today. The difference today is that some are going to be what we call monomials, some are binomials, some are trinomials. I hear someone's music. Turn it off. So if you're listening to music right now, turn it off. Okay, if I have to go find out who it is, I'm going to take 10% off your next test because that's the rule. So if you have that, turn it off. Did you hear what I said? Thank you. Okay. Okay, here we go. Now, let's look at these. So to do this, we're going to factor the top, factor the bottom, see what cancels out. That's all we're doing. Okay? So 15. What does 15 break down to? 5. Just 5? 5 times 3, right? Now, does 20 have a 5? 5 times 4. And they also have x's. So the top has x. It's all multiplication. The bottom has 3 of them. So we're doing the same exact steps we just did. 5 divided by 5 makes 1. X divided by x makes 1. What's left? Well, the top has 1 times 3 times 1. 3. The bottom has 1 times 4 times 1 times x times x. 4x squared. Okay, that's the only difference when you have letters. Not really a difference. Okay. Letter B. What do they have in common? What do 90 and 99 have in common? 9. A lot of you can see that. Some of you can't. I understand that. Some of you are like, Mr. Flores, I don't know what goes into both. That's fine. If you don't know what goes into both, I have a step for you. Break down 9. Break down 90. 9 times 10. 3 times 3. 5 times 2. So it's 5 times 3 times 3 times 2. $99. 9 times 11. And then 9 is 3 times 3. 11 can't break down either. That's it. And then the top has x times x. Now, if you automatically saw 9 goes into both, you don't have to do all this. I just get the question a lot. I don't know what goes in. So that's why I'm doing it. Okay, I don't need to see all of that. But if you need to, do it. Okay. So now we have 10x squared over 11. Okay. Last one. 15. 5 times 3. 16 is 4 times 4, or 8 times 2. Even if I break down 4, it's still 2 times 2, right? So there's nothing that cancels out. Sometimes that happens. Sometimes you're dealing with a fraction that's already been reduced. Okay? All of these guys, everything on the first page was what we call a monomial, one term. On the inside, we're going to have binomials and trinomials. So how do we do that? Well, you've done it before. Okay, so it's got a numerator, it's got a denominator. The numerator is the top. The denominator is the bottom. How do I factor the top, the yellow? How do I factor the yellow? Yeah, we've done it before, right? We've done it, not only have we done it since I think September, you guys did it last year. How do I know that? Because right now in Math 2, they're doing that. This is what they're doing. They're factoring trinomials and binomials. Okay, so you guys have been doing it for a while. If you don't remember, that's why I left the steps on the board. Leave the steps on the board. I left them on there because we always come back to them. Yeah. The yellow is a trinomial. It's got 3 terms. So, does it have a GCF? Does the yellow have a GCF? Besides 1? No, yeah. So we skip that step. We go to ABC. A is 1. B is -7. C is +6. Multiply A times C, you get positive 6. B is negative 7. So now I need the two numbers that multiply to be 6 and add to be negative 7. Negative 6 and negative 1. Yeah, we've done this many, many, many times. So we get x squared minus 6x minus 1x and then plus 6. So it's x times x. And then you're going to get x minus 6 and x minus 1. Okay. Top is factored. Now we got to do the bottom. So that was the yellow. So I'm going to highlight this in yellow. This is how I factored the yellow. Now next to it, I'm going to do the same thing, but I'm going to do it for the blue now. A is 1. B is negative 5. C is positive 4. A times C, 1 times 4 is 4. B is negative 5. What are the two numbers that multiply to be negative or positive 4 and add to be negative 5? Negative 4, negative 1. Okay. So x times x, we get negative 4 and negative 1. So x minus 4 and x minus 1. Okay, step 1 done. They're both factored. Step 2, look for giant ones. Shared factors that cancel out. Is there anything that cancels out? They have to be the same. I see a lot of x's, and I'll show you watch. So those cancel out. So we're left with x minus 6 and x minus 4. I'm going to ask you a question because I see this a lot. Can I do this? Can I also do that? So can I also get rid of the x's to make negative 6 over negative 4? The answer is no, not if you want to get the question right. I can't do that. I can't do this part here. Why not? Because I can't cancel out one term if they're binomials. Binomials mean they go together. X minus 6 goes together. X minus 4 goes together. I can't pick and choose from there. Now, if there was an X over here and an X over here, go for it. Because those guys are monomials. Those guys are lone wolves. They're by themselves. There's nothing there. So be careful when you're simplifying. You don't want to do that. Okay? Because they're part of a team. Binomials are part of a team. I could only cancel out if the whole team is the same. That's why they're called binomials, because there's two parts. Both parts have to be the same. Okay? Even if you had one like this, sometimes I'll have one like this. They're almost close. One's a plus and one's a minus, but they're not the same. They're very close. It's like a team who plays in the same city, right? It's like the Los Angeles Rams and the Los Angeles Chargers. They're both very similar, but they're not the same team. They're different. Okay? Even if they share the same team location, they're not the same. So be careful when you do that, because I see a lot of that. I see a lot of those mistakes. Okay? Okay, next one. Try the next one on your own, in fact. Do the next one on your own. Do letter B, 3B on your own. Oh, it should be positive. Yep. Thank you. Yep. Yeah. Double check my work because I make mistakes all the time if I'm going too fast. Okay. So there's my blue, and there's my blue factored and yellow factored.
So when you put it like back into the fraction form, does it matter which binomial?
Oh, order. So are you so like this?
Yeah.
Yeah, that's a great point. Can I do that? The answer is yes, because it's this binomial times this binomial. It's multiplication. And in multiplication, it doesn't matter which one you multiply first, right? Like 3 times 8 is the same as 8 times 3. So that's a great question. Do the order of the binomials matter? No. Now you have to have an x plus 1 and an x minus 2 on the bottom, but does it matter which one comes first? No. Yeah, great question. Okay. Okay, so I see that these two teams are exactly the same. So I have an x plus 5 and an x plus 1. Now these two binomials are close. They both have x's, they both have pluses, but they're not the same. So I have to leave it alone. You're done. You are done with that problem. Okay. All right. Okay, let's do letter C together. Okay. So I have top. I have bottom. Okay. Top is a trinomial. It's got 3 terms. X to the third, negative x squared, negative 42x. It's got 3 terms. So, same thing with the bottom. It's got 3 terms. But what are the differences between this one and the 2 problems we just did? GCFs. Yeah, they have GCFs. The guys before didn't. Okay? So if they have GCFs, let's do that first. So the first guy, what can I divide all of them by? X, right? X to the first power. X. So that GCF always goes in front. That's x squared minus x minus 42. Bottom also has a GCF. What is that GCF? 2. You can divide them all by 2. If you can do that, do that. If you can't, don't do it. Divide them all by 2. Now we go on. So that was just step 2. We haven't been able to do step 2, but now we can. Okay, so now the yellow. A is 1, B is negative 1, C is negative 42. So A times C. So the two numbers that multiply to be negative 42 and add to be negative 1. Negative 7, positive 6. Okay. So we get x squared minus 7x plus 6x minus 42. Okay, GCF is still in front. Always in front. That was the yellow. Now let me do the blue. A is 1, B is -10, C is 21. So I'm looking for the two numbers that multiply to be 21, add to be -10. -7, -3. And positive 21. Okay. X minus 7, X minus 3. And then GCF in front. That was the blue. Okay, so now I'm here. Giant ones. Anybody exactly the same? Yep. X minus 7, X minus 7. Anything, the same thing divided by itself makes 1. Doesn't matter what it is. 1 times 1, 10 times 10, 12 times 12. Any number divided by itself, anything divided by itself makes 1. So I get X in front, X plus 6, 2 in front, X minus 3. Okay. Let me say, before we go into the next one, let's say I had a 2 in front of there. Let's say the GCF was 2x. Could the 2's cancel out? But they're not. So these guys are monomials. The guys in front, the GCFs, they broke away from the trinomial to make monomials. So these guys you can't. So if there was a 2 there, you could do that. You could do that. Okay? The reason we can't touch these guys is because they're binomials. Okay? Once they become monomials, then they have different rules. Right? They have different rules. Okay. Let's go this guy. Okay. Got to factor the top, factor the bottom. The top is a trinomial. Same thing we've been doing. Doesn't have a GCF, so you can move on to the next step. A is 1, B is -11, C is 28. Multiplies to be 28, adds to be -11. -7, -4. Okay, so we get x times x, so we get x minus 7 and x minus 4. No GCF this time, so it's just x minus 7 and x minus 4. The bottom. Bottom is not a trinomial. Bottom is a binomial. So we can't use the same rules we did on trinomials. Binomials is right next to it. It's got less steps. First step, factor out a GCF. Well, does the blue have a GCF? It does. I can divide it both by x squared. Take away 2 powers, I get x to the first power. Take away 2 powers, no more powers. Minus 4. Those can cancel out. So I get x minus 7 over x squared. Okay.
Jessica's supposed to call me at 11:50. Can I go check with the office?
Yeah,
real
go
quick?
ahead. Okay. So letter B, we got 2 more. 2 more, that's it. I'm not going to give you any more extra problems. Okay. 2 more, and that's it. Okay, so the next one. Okay. Top is a binomial, bottom is a trinomial. So binomial steps. Does it have a GCF? Nope. Is it difference of squares? Does it fit into one of these guys? We haven't done this in a while. Right there, right? 25. It's got a squared. It's got a minus. Yeah. So it's going to be x minus 5, x plus 5. Okay. Bottom is a trinomial. A is 1, B is negative 7, C is 10. Two numbers that multiply to be 10, add to be negative 7, negative 5, and negative 2. Minus 2x. So we get x minus 5 and x minus 2. Okay, last step, look for things that can cancel out. X minus 5 and x minus 5. Okay. All right, one more. Last one. Okay, so I got the top and I got the bottom. The top is not a binomial. It's not a trinomial. It's a monomial. It's got one term. So we're going to break it down like we did in the front. Like we did right there. We're going to break it down like how we broke down these guys. So can 7 break down at all? Nope. So it's just 7 times x. Bottom is a binomial. Does it have a GCF? Yeah. 7x, yeah. So we got 7x here. And then I get x plus 7 here, right? Got a lot of 7s. Can I cancel any of them out? So you can cancel out monomials with monomials and binomials with binomials. Okay? So, Emma? There you go. These two are monomials, right? I can cancel those out. Yep. This guy here is a binomial, so it can't cancel out with anything other than a binomial. So these guys, I can cancel out. And the x's too. Another question, what's left on top? Not 0. Yeah, because those are giant 1s, right? So 1 times 1 is 1. That's why I use the giant 1s, just to help me remember, hey, they're 1s. They're not 0s. So 1 times 1 is 1. Okay. All right, so I'm going to pass out the tape.